In this lesson, we're going to be looking at determining angle measures using sine law. In the last video, we looked at determining a side length if we use the sine law. And so this time we're going to look at a missing angle. So we're going to be dealing with oblique triangles again. We're going to be applying the sine law. We're going to show how to use the sine law. And we're going to describe how the sine law is used in problem situations. Our outcomes are just solve a problem using the sine law when a diagram is given. So if we know the two sides in an opposite angle, we can use another version of the sine law to find a missing angle. This is different from when we were looking for missing sides. In that case, we had two angles and a side. This time we have two sides and an opposite angle to one of those two sides. So for triangle ABC, we can rewrite the sine law in a slightly different fashion. What we've done is we've flipped all our fractions over. So now we have sine A over A is equal to sine B over B, which is equal to sine C over C. Side A and angle A are still related, as is sine B and side B and angle B, as well as side C and angle C. Okay, so the types of triangles we're dealing with now are called side-side angle triangles. And this is because when you look at the triangle, we start at one of our sides, and if we travel in this fashion, the given information we have is a side, and an angle. Okay, so it's an SSA triangle we refer to it as. So we're going to look at this triangle, and we're going to actually solve for angle x. I'm going to show you how to do the sine law. We're going to do this one by hand. So the first thing I'm going to do is set up my my ratio. So if you recall that for sine law, we have sine of A over side A is equal to the sine of B over side B and equals sine of C over side C. But there's no need to draw out all three of those. I'm going to call angle x, I'm going to refer to it as what is A we're looking for in this problem, which means that the 20 centimeter side is side A. That means the 31 degree angle is going to be angle B, and the 15 centimeter measurement, that's going to be side B. Okay, so I'm going to fill in my given information into the problem. So sine x over 20 is equal to sine of 31 degrees over 15. Okay, once again, now I can cross multiply if I want to get rid of these fractions. I'll show you another way in a minute. But that means we now have 15 times sine angle x is equal to 20 times sine 31 degrees. Lastly, we're looking to get x by itself. That's the ultimate goal here. So to do that, first I have to get sine of x by itself. So I'm going to next divide both sides of my equation by 15. Bring up here, I got lots of room over here, which gives me sine x is equal to 20 sine 31 degrees over 15. Now at this point, what I'm going to do is go to my calculator again. So this is what my calculator looks like on the computer. I've actually gone through and solved it, but we'll start over again. So what I'm going to do is I'm going to type in 20 times, for me I type in the angle first, then, oh, I missed the first button, times 31 sine, and then divide that by 15, and I get 0.6867. So I'm going to stop sharing at this point and go back. And so that means that sine x is equal to 0.6867 and a whole bunch of other numbers. But 4 decimal numbers is fine at this point. So if I want to find x, there's a special button on your calculator. Depending on the calculator you use, it's usually a second function button on the sine button itself. So you type in second and then the sine button. It's going to look like this. I'm going to have x is equal to what we call the inverse sine, sine to the power of -1, 0.6867. Okay, so I'm going to go back to my calculator. So I've got 0.6867 on the calculator right now. For me, I have, on the computer calculator, I have this button called INV. That's inverse. On your own personal calculator, it will probably be a shift or a second button on it. And then I'm going to hit that. And now you may notice, if you're able to follow along exactly as I show it here, that when I hit INV, the sine button becomes sine to the power of -1. So I just click that now, and it gives me my final answer. So the sine to the power of -1 of 0.6867 is 43.37 and a bunch of other numbers degrees. So when I'm back here now, I've got x is equal to 43.37 degrees, or it's equal to 43 degrees. And that should make sense in the context of this problem, because the side opposite this 43-degree angle, which I'm going to write in over here, x is 43 degrees. The side opposite the 43-degree angle is 20 centimeters. The side opposite the 31-degree angle is 15 centimeters, which is a smaller number. So the smaller angle has a smaller side opposite. So it does make sense that that would be a 43-degree angle in this case. Okay, so we're going to look at this example here. Determine the angle measure using the sine law. A pulley winch in an automotive shop is suspended from a ceiling by 2 support chains. One of the chains is 2.4 meters long and forms an angle of 55 degrees with the ceiling. The second chain is 3.5 meters long. Use the sine law to determine the size of the angle that the second chain makes with the ceiling to the nearest degree. Okay, so we can see right down here that I have a 55-degree angle right here. And the angle I'm looking to find is this one right here. I'm going to call that x again, right here, for now. Okay, so using this diagram, I'm going to simplify it a bit. I mean, it doesn't have to be that elaborate. It's just a triangle that we're worried about. So I'm going to draw a triangle. And I'm going to label it triangle ABC. We've got our sides, little a, little b, and little c. And in this case, angle A is 55 degrees, and side A is 3.5 meters. Angle B is what we're looking to find. Right, so angle B right here is what we're looking to find. And side little b is equal to 2.4 meters. So in triangle ABC, we know angle A, side A, and side B. So we're looking for angle B. So to set up our sine ratio, or sine law, I should say, we got sine A over A equals sine B over B equals sine C over C. Well, sine C over C, totally unnecessary in this case. We don't have to worry about that part at all. So we're going to simplify it down to sine A over A equals sine B over B. So we fill in our known information. Angle A was 55 degrees, side A was 3.5 meters, sine B we're looking to find. And side B is 2.4 meters. So we can cross multiply. Of course, another way we can do this right now, if we want to get sine B by itself, this is the other way I was referring to. Right now we're dividing sine B by 2.4. So to get sine B by itself, we do the opposite operation, which is to multiply sine B over 2.4 by 2.4. So that's what we get here. I'm multiplying both sides of my equation by 2.4. Because in order to get rid of something when you're doing an algebraic problem, you always perform the opposite operation. Initially, we were dividing by 2.4, so now we multiply both sides by 2.4 and gets rid of it. So now we have sine B is equal to 2.4 times sine 55 degrees divided by 3.5. Okay, so on the calculator, I'm not going to go back to the calculator app, but these are the steps we're going to put into our calculator. So we start by clearing it. C is to clear our screen. We put in bracket, type in 2.4, then times the sine button, 55, close your one bracket, and close your other bracket. Divide that all by 3.5, and it gives us a value for sine of sine B of 0.5617 and a few other digits. So 0.5617 is equal to sine B. Now once again, we've got sine B isolated, but we want to get B by itself. So we're going to perform that inverse sine function again. So B is equal to the inverse sine of 0.5617. So on your calculator, like I said, you're going to see likely a second button, or possibly a shift button, or if you're using the computer's calculator, you have an INV button. So when you hit the second button, then usually above sine, there's this sine to the power of -1. So you'll activate that, on your calculator, type in the ratio, which is 0.5617, and a few other numbers. And that gives us a value of 34.17 and a bunch of other numbers. So that means that angle B, to the nearest degree, is going to be 34 degrees, because the first decimal number is 1. When we have a 1, we round down, or in other words, keep the angle where it is. So angle B in this case is 34 degrees. So to summarize this, once again, we're using sine law because we don't have a right triangle. We didn't have a right triangle in either of the examples we looked at today. And when we don't have a right triangle, we can use the sine law to find a missing angle in a triangle if we know two sides and an opposite angle. So SSA triangles. The sine law in this case is going to be sine A over A is equal to sine B over B, which is equal to sine C over C. And again, we only need to use any two ratios at one time. We don't necessarily have to use all three, and in fact, it makes it very difficult to try to use three ratios at once. So we only ever use two ratios at one time.